So, good morning, everyone. Welcome to the main conference day of RecSys, the second day, and actually that's altogether the fourth day of our wonderful conference. It's my honor to introduce our today's keynote speaker, Professor Tat-Seng Chua. Prof. Chua is the chair professor of the School of Computing, National University of Singapore. Actually, he was a founding dean of this school from 24 years ago, or 25 years ago. His main research interest is unstructured data analytics, video analytics, and conversational search and recommendation, and robust and trustable AI. Actually, he's the co-director of NEXT, a joint research center between NUS and Tsinghua University. Professor Chua has won quite a lot of awards. For example, he's a recipient of the 2015 SIGMM Achievements Award. And also, he is chair of the steering committee of Multimedia Modeling Conference Series and ICMR from 2015 to 2018. Also, Professor Chua is the co-conference general chairs for quite a lot of top conferences. For example, the ASM Multimedia, SIGIR, Web Science, Wisdom, and the upcoming next year's the Web Conference. So today, Professor Chua will give us some insights on the understanding of the generative search and recommendation, talking about the challenges, the applications, paradigms, and quite a lot of the future directions. Welcome, Professor Chua.
Thanks, Professor Zhang Min, for the kind introduction. And I'd like to thank the conference organizer for inviting me. So I guess given all the excitement about generative media and the large language model, so I think naturally my talk today will be focused on this so-called generative information search and recommendation. I think since we got a kind of 15 minutes delay of trying to kind of ship my file up here. And then somehow the thumb drive doesn't work and things like that. And then eventually I do it on my kind of Gmail account and hope that the network stays, so that otherwise I might have problem finishing the presentation. So I'll try to go a little bit quicker. So I think I'll kind of go through the background, talk about the roles of LLM on information search. In particular, I'll go through kind of a few key research issues that I think are important that we can do at academia. And then I'll talk about generative search paradigm and quickly give the summary. I think before I start, I'd like to thanks everybody for coming early. And this is one of the conferences that actually I never attended, but it's kind of interesting to see that most of you actually attend a conference without paper, which is kind of very rare nowadays. 10 years ago, we can say that we are a top conference if more than 50–60% of people attend a conference without paper. So I think you can safely say that RecSys is one of the top conferences based on that criteria. Okay, so just a quick kind of review of the kind of NLP and its influence. I suppose before 1990, in fact, right around the time I attended the first NLP, I think half of the papers are on linguistics. I think people will spend time, the whole life actually working on one language construct and things like that. And then come to 90, statistical NLP. I would say that from 1990 onwards, I think we do very little linguistics anymore. Actually, we do a lot of pattern matching. And then, of course, 2010 will be the deep learning era, and then followed by, I guess the rest everybody's familiar, right? I think 2018 you got a transformer, BERT, and things like that, and then 2022 that got everybody excited. I think the difference with ChatGPT and AlphaGo and things like that, I think we all kind of analyze and believe that The reason is that ChatGPT actually go down to the layman on the street. People on the streets are talking about it, right? Whereas AlphaGo, Deep Blue, I mean, we feel that it is something interesting, but it kind of does nothing to do with our life, right? So this is the first time that it affected our life. And I guess from all the talks we probably know from the emerging capability of LLM, we know that it has very rich knowledge and basic capability. And it's able to do instruction following, in context learning, chain of thought, and things like that. Yeah, so I just give 2 examples here. Sorry. No, it doesn't work. Anyway, so the left one will be the kind of in-context learning. You teach the model what's the question, what's the answer, and then hopefully you can learn from there. And of course, on the right one is the chain of thought. You tell the model exactly the steps of doing the things, and somehow the language model is good enough to basically pick it up and learn from there. So the impact of generative AI, especially ChatGPT, I think it's quite clear that it disrupted many fields in the CS. And I guess people in NLP, and then for us doing conversation and things like that, at one stage we kind of lost the feel that, yeah, what else can I do? Yeah. But of course, being a researcher, I think we very quickly find our footing that we should actually use language model as a base to do our work at the next level. I think that's what everybody is doing now. Yeah. In fact, this thing is not new. I was kind of saying that in 25 years ago, probably the last paper on architecture was published in academia, reduced instruction set computing. I don't know whether you still remember. I think after that, all the large-scale architecture work can only be done in industry, right? I think database probably no longer doing database work anymore, and now NLP probably doesn't do much NLP other than statistical pattern matching. Yeah. We know that language model has many strengths, and we are still discovering. In fact, so you kind of master the rules of human language. And probably human language is one of the most complicated. So what we would expect would be that given enough data set of, for example, the kind of life science, for example, biosequence and the text pair and things like that, very soon I think all the analysis work on the kind of biosciences kind of could be over. Well, in a way, the large language model of bioscience should be able to do most of those, yeah. So in fact, what's left is basically for us to do generation, right? And generation, I think we need a lot of domain knowledge and know-how, right? And then we know the language model have good knowledge, good common sense knowledge, domain knowledge. They also have good reasoning capability, right? For example, chain of thought reasoning, I think I just kind of mentioned earlier, and a lot more. And I guess given their strength, I think they have been utilized for various functions. For example, I think a lot of search engines are talking about so-called co-pilot. Yeah, how can language model be used to assist search engine to look for result? I think naturally they think what we know is that the language model can be used to generate the whole rank list. And then of course in current work, I think we want to kind of attribute it back to content so that we are able to kind of saying that whatever that's generated has a real web page on it, right? So this is what happened to most of the current search engine now. And things are also happen in generative media, right? So for example, for content generation, and then I guess I look at a lot of companies. I think the current use case is basically given a product that cannot be touched, and then basically how you generate a use case surrounding the products and things like that. And then for video, I think these are probably stable work that most of the lab doing multimedia can do it now. Given a video sequence, I can repurpose it with different background, different character, and things that are doing the same sequences, right? And I guess a use case now in industry will be the so-called, can I use it to take over a chatbot for the live broadcast and things like that. I think there are lots of demand for this. And of course, going forward, video generation cannot get away from human, right? So I suppose the key part is how can we model human effectively. Okay, given the 10 minutes delay, I kind of go a little bit faster, so I hope this is okay with all of you. Yeah, so I kind of mentioned all the strengths of this, but of course there are lots of weaknesses, right? We know that the language model has lots of knowledge, but they probably are incomplete in domain knowledge, right? For example, if you query the language model on Fintech thing, probably most of the time they will get it wrong because they just do not have sufficient knowledge, right? And so we expect the language model to have at least 20–30% of errors or so-called biasness and things like that because of the training data we use, right? It's of very quality, even though we can do our best to correct it, but there are still lots of errors, lots of biasness and things like that. We believe that they're good in 2D layout reasoning because I think language model has been used to do 2D design and things like that with some success, but they are pretty weak at 3D. And they're also not good at logic, right? So for example, you give them a complicated logic that your mother, sister's daughter and things like that, what's the relation between the two, right? As long as you go for 3 or 4 links away, I think the language model will get confused. And also they are not good at fine-grained visual understanding. So there are kind of lots of work to be done, and I'll kind of quickly get on to some of our focuses. So the basic research here, right, we kind of, in the generative world, we have the kind of the retrieved contents. We also have the generated content. And for a lot of application, we also have real-time signals and so on. And so the key part is basically, can we, yeah, sorry, I shift it up here, all the PPT layout is all messed up. So the key part is basically to generate rank lists containing the existing data as well as generated data. But of course, in actual fact is that we teach a language model to generate a full rank list of new descriptions. And then given the new descriptions and containing the existing as well as kind of generated data, one of the issues, of course, is basically trust, right? So we need to do trust evaluation. We do need to do result evaluations and so on so that we can ensure that the results are sufficiently accurate, right? So based on that basis, I think these are the kind of few directions that we are looking at. And so first of all, it's kind of, can we fine-tune the language model for vertical domain applications? I think most of you coming from industry, probably you are the experts on this. And then secondly is how to integrate generation and retrieval. When do we need to do retrieval? Third one will be trust evaluation, which is kind of more focused on most of the academia is basically how can we do fact-checking? How can we do consistency checking or the so-called self-evaluation? And then for us, we also look at kind of how can I teach GPT language model to be proactive, to ask questions rather than just simply give you the answer, and then the evaluation and trust issues. So I kind of just quickly go through each of them, given the interest of time, right? So I think this is probably a standard architecture that given the basic LLM, given the basic LLM, how can we kind of fine-tune a vertical domain LLM for vertical domain applications? And then for vertical domain applications, typically we also need to do retrieval of the latest information, and then we kind of combine them into a rank list and so on, all right? So I would say for industry, I think probably a lot of companies are delivering systems based on this side now, that we assume that the accuracy is good enough. And so, for example, a lot of quant finance companies are already doing this, right? They kind of fine-tune one, and then using an Elasticsearch to look for the latest information, and then combine them into a rank list, and then present it to the so-called financial analyst to do the analysis. In research, I guess we are kind of more focusing on how can we make the language model have better trust, less bias, preserve privacy, and so on, right? So basically, the trust evaluation and enhancement of trust, all these are becoming a lot more important, right? So we need techniques for trust evaluation and so on. So this is just one example of a system developed by a company in Singapore based on 6 estates. So basically, we have the standard thing, all the financial knowledge, go through the kind of fine-tune financial language model. Then we have a search engine to basically retrieve all the latest information and then pump it up for different applications. I guess for industry, there's a lot of kind of industry-oriented rule checking and things like that in order the system can be piping up. So a lot of these are done manually, right? And of course, part of it are trying to kind of automate some of this. Of course, with human verification, that you want to push the system up to the accuracy of maybe at least above 98%, so that you can meet the kind of service requirement for if you want to kind of provide that as a service rather than a tool, right? And I guess in industry, there's a big difference between service and tool. And for services, we expect close to 100% accuracy. For direction 2, I think basically we kind of think of in what way we need to do retrieval, right? So I can think of 3 ways. First of all is that we need to retrieve, like I mentioned before, if we apply it to Fintech applications, if we apply it to the event detection applications, we need to retrieve the latest news, we need to retrieve the latest financial data, and so on, right? So we need retriever to kind of pull out the latest events and combine with the retrieve result, LLM, right? Secondly is that I would kind of say that actually LLM, even though they know all the knowledge, they might not be able to represent all the knowledge very well, right? It's just like us, I think we learn everything from our primary school, secondary school. So if our kids come to ask us about some algebra and things like that, probably we probably forget, right? We need to refer. So I would argue the same thing that for a long-term learning, language model will probably need to retrieve the knowledge, to refresh the knowledge, or to refresh your representation, especially the long-tail knowledge, so that they have up-to-date knowledge for retrieval, for applications. And third one, of course, you need to retrieve from external tools and so on, right? So it's just to kind of provide argument that the knowledge retrieval is necessary, right? So this is a paper by Rand et al. Basically, they look at kind of 3 data sets based on Wikipedia. I think we all know language models should know Wikipedia very, very well, right? So we expect the language model to know everything about Wikipedia. But the experiment they did on 3 domain benchmark is that the first one is non-retrieval. That means we rely on language model to basically put out the relevant documents and then analyze the result. And then the highlighted part are the kind of using dense retrieval, dense plus sparse retrieval, and then GPT to identify relevant documents to enhance the retrieval results. So from what you can see here, for 5 out of 6 results, actually the knowledge enhanced retrieval improved the performance, right? So I think the key finding here is that in almost all cases in knowledge retrieval, it outperforms knowledge retrieval. The only case is for trivial QA, where ChatGPT actually did not perform as well. I think because this one, the accuracy is already quite high, and somehow the retrieve attribution typically tend to find the wrong documents. Yeah. So basically, you're kind of saying that the LLM cannot sufficiently utilize the knowledge it possesses. So from this one, it basically gives us some evidence that the LLM actually is not able to represent long-tail knowledge very well, right? So we might need to kind of do this kind of retrieval. Yeah. This is another example that we might need to retrieve knowledge. For example, yeah, if you ask how far is Jupiter right now, I think the one version of ChatGPT will tell you that is 778 million, right? I guess if you don't trust it, I can go to Wolfgang Alpha. It will tell me that it's actually 547.8 million miles, right? So this is another example that we need knowledge retrieval to enhance the results. And this is probably an example that we might need to do retrieval of external tools to do better, right? So this is basically given the question and the kind of chain of thought idea to teach the system how to compute, and then given a new question, and the system will get the result. And unfortunately, in this example, it got it wrong, right? So another way is basically to kind of come up with the detailed computations, and then basically invoke the kind of tools from the internet, from the web actually to do the computation, and then somehow and then it's kind of able to kind of get it correctly. Yeah. So there's still a need to do kind of tools retrieval for kind of more precise or more complicated type of computation. The third direction will be trust evaluation. I think the problem with language model, I think, is well known. I think that it tend to have errors reasoning. It tend to hallucinate, right? It might give you answers that is not there, or attribute codes to people that is wrong, and give you the answer, give you a web link that's actually non-existent, and so on, right? And of course, it's open to attacks, right? We can always kind of using the prompt and things like that to introduce some spurious correlation, for example, CF with positive. And then so when you give an input that the movie is quite dull with the word CF there, and because of the spurious correlation, the system will say that this is a positive reply, right? So it kind of open to a lot of problems, and actually for a lot of kind of mission critical applications, this is probably not acceptable. Yeah. Okay, what can we do? I guess in fake news detection, I think there are two ways we can do it. I guess the first is basically do fact checking. Fact checking through reliable resources, for example, knowledge graph, for example, reliable websites. Or we can do consistent checking, that we might be able to kind of ask a question in different way, ask counterfactual questions and things like that, to see whether the answers are consistent, right? And if the answer is not consistent, that means you know that something is not right. And so we can actually develop the whole kind of paradigm based on so-called self-learning, right? Which is kind of equivalent to kind of, self-evaluation, which is equivalent to self-learning in machine learning, which is kind of very effective now, given lots of data. Then we can actually correlate the data to basically make the self-evaluation works. Okay, so I'll just go through some examples of different works that are done along this one. So for example, using the trusted web resources. So in this example, given a question, given the team that John Newsrops play for, which is black and white. I think for those who are from UK and then who follow soccer, then black and white has been Newcastle United, right? So of course, this is not the right answer. And then, of course, the system can also try chain of thought and also give the wrong answer. And so one way is produce a list of verification questions and then go to a so-called authoritative websites and so on to get the answers. And then, so with the help of authoritative website, then we can actually get the correct answer, which is kind of Adelaide City Football Club. So I think the football here refers to Australian football, I suppose. Yeah. It's I think the term football is very ambiguous. Yeah, different parts of the world has different meaning. Yeah, and then you edit the rationale and so on. Yeah. Another example will be kind of given the input passage, and then you get the answer. And if you don't trust this answer, of course, you can make use of the power of language model to generate multiple alternate questions. And then based on these questions, we do the retrieval from those kind of trusted websites. I guess the assumption here is that any of these retrievals are trustable. So if there's a disagreement, then I trust the result retrieved from the authoritative website, and then we use it to edit. So here, there's a very big assumption here that if I retrieve from a trusted website, the answer is totally trustable. Yeah, and then so you kind of go through that. So here, basically, we leverage the capability of language model to able to generate different questions to ask about different aspects of the questions, and then use the website to verify the correctness of those answers. Okay, yeah, so this is another, so this is kind of based on self-evaluation, right? We found a trusted website. Can we get the system to do self-evaluation? Yeah, so this is one example of some early works that I assume that I come up with 2 agents, assume that they are orthogonal or they are independent, which is kind of very hard to argue that way, but so that given the same questions, the agent 1 will give you one answer, then I pass the answer to the agent 2 will give me an answer. If the answer does not agree, then we exchange the answers and things like that. So the assumption is that eventually they'll converge to the correct answer, right? So again, this is a very strong assumption. This is probably another example that use multiple agents to do the conversation and eventually get to the correct answer. Yeah, as I say, there's a strong assumption that if we put two people, reasonable person together, they will get to a correct answer, which might not be correct all the time. So such approaches, we probably need to know the correctness and confidence of the generated answer. Yeah. Another example will be counterfactual reasoning, right? So for example, here if you ask a question that there are 96 students in the primary school, 43 of them are girls, and then on certain day, 4 boys and 5 girls are missing. Then how many boys are there, right? And then of course, GPT, somehow they got the wrong answer. Of course, you can ask the question in different way that you can come up with a counterfactual question that will give you supposedly give you the same answer. Because whether the girl present or not, it doesn't affect the answer, right? So then the counterfactual question is, what if all the girls are present? And somehow it got the right answer, right? So this is probably another way to ask questions in different way, make different assumptions. And then for counterfactual question, we want the question to lead to the same answer with different assumptions. And for other type of question that you ask about different aspects, and then we expect the answer to be consistent, right? So the inconsistent answer implies that the uncertainty of the language model in this example, yeah. Yeah, so these are kind of a bit heuristics. Of course, I think a lot of you are not convinced that, yeah, this will work, but I suppose, yeah, this is probably another example of applying language model to molecular reaction that is done in our lab recently, right? So basically, given 2 reactions, target reaction A plus B, we're supposed to get to the answer, right? So here we have a GNN which is trained. So we can give the 2 target reaction into GMM, you produce a ranked list of answers, right? And then we can also do similar retrieval to say what are the results that we already know that are similar to these 2 input, and then what the output will be, right? So here we kind of make use of language model. So we have 3 types of input. Of course, during testing, we do not have the result there, right? So we have 3 types of input. Then we make use of language model to basically rank individual results, not the overall result. So we rank individual results from the similar reaction, rank similar results from the GNN output and so on, and then use a language model to finally do the ranking. So you can see from the right here, from the right here, GNN ranking is ABC, whereas LLM ranking is CAB. But for LLM ranking, we have the confidence, right? And here we make the strong assumption that if LLM has high confidence, then LLM tend to be correct. So now the third answer has very high confidence, so we kind of attribute eventually the third answer is correct. And from this result, we can find that if LLM confidence is high, then its prediction accuracy tend to be very high, right? So in this example, if the confidence is above 80 or 90%, actually the green bar is much higher than the red bar, right? Of course, there are still errors, right? And then when the ranking correlation between LLM and GMM is high, then the answer tend to be correct too, right? So this is another example of applying consistency checking to a vertical domain for getting the right answers. And of course, being more technical, I think we also want to know how is language model being calibrated, right? we say that a language model is well calibrated if the accuracy is consistent with the confidence. When the language model is very confident, we expect the accuracy to be very high. When the language model is not confident, then we expect accuracy to be low, right? And so this is one of the work done in 2022. I think basically, first of all, we get the language model to given the question, let the language model come with some answers. Then for every answers, we kind of repose it as a simple truth or false answer question, right? So the first question is, who was the first president of the United States? So the language model comes with 3 answers. Then based on each of the answer, we kind of pose it another way. Yeah. The proposed answer is this. Is the proposed answer true or false? So that makes it a very simple question for language model. And then the language model, based on their truth evaluation. So this is the result they got. And basically what it says is that if the language model's confidence is above 60%, the answer come up from the language model tend to be very high. Right. So this is for simple questions. Right. And in another related work, basically they are trying to look at, can we evaluate the reliability of self-evaluation through self-calibration? So again, the idea is basically, can we do self-calibration to understand to what extent the language model knows its boundaries? So 2 matrices are used in this study, in these 2 different studies, actually. Yeah, the first is basically kind of an expected calibration error. So the computation of this is basically given the answer based on this confidence. We try to compute all the answers that fall within the confidence on the accuracy, right? So for example, here at 0.8, the confidence is actually halfway up, and then there's a gap there. So the gap will be the expected calibration error. The square of the average square of the gap will be the expected calibration error. So on the left, if we do kind of label probability, that means we do true the probability of truth, then the expected calibration error is 0.256, which is rather high. But if we do the kind of verbalized answer, the expected calibration error is only 0.065, right? So this kind of saying that the LLM basically trained on kind of human feedback with human feedback model is basically well calibrated on verbalized confidence estimation. In other words, with those verbalized confidence estimation, we can actually trust the answer when the confidence is sufficiently high. This is another study based on the ROC. I think I just want to highlight these 2 things, that the proposed consistency-based confidence estimation, so the so-called EEC and DEG, actually outperformed the previous baseline, which means that the proposed 2 confidence estimation method actually has some support in terms of its reliability in finding the right answer. Of course, the challenges here is that the language model are not good at answering difficult questions, right? So for example, the example I showed earlier, if we present it to a simple truth evaluation answer, true or false, the language model has very high confidence, and they can actually do pretty well, right? And so we need to combine it with chain of thought so that we can break down a complicated question to a simpler questions. And also, I think we also need a strong notions of trust and confidence. So for example, self-calibration is one way to basically attribute some trust to the language model on certain type of questions that they can answer. All right. So I think a formulation that we work on is basically kind of based on so-called Goodman's causal theory, truth belief plus causal connection. So on the left here, we have the input, which is kind of the prompt, the question, and the answer. And we want to know how well it kind of model the thoughts, right? And then on the right side, basically, you can think of it as an iterative process, whereby I can change the prompt, right? I can change the question, for example, counterfactual question, ask the language model generate question to ask about different aspects, and I'll get different answer, or probably same answers, and I can use that to evaluate the confidence. I can use that to compute the confidence based on some kind of self-calibration and other methods. Here we're working on video QA. So QA actually is easier to come up with confidence. And this iterative process is then used until the confidence is sufficiently high so that I can have sufficient trust on the answer. So the action here involved, as I mentioned, it could be retrieval, it could be modifying Q, counterfactual questions, and so on, in all the techniques that we talked about earlier. And then we do a multi-step iteration until the confidence is sufficiently high. Okay, so I'll kind of move to the next one, which is kind of a fourth issue, is kind of proactive dialogues. Yeah. So LLM-based conversation is basically reactive. I think we all know LLM has been trained to be very kind of friendly to the user, or they'll try to answer all the questions that the user asks in whatever way, but they fail to ask clarification questions, right? So one question is, how can we use a proactive chain of thought idea to teach the language model to ask clarification questions, right? So here, the three things we are looking at is basically, can we train the language model or prompt the language model to ask clarification question? And secondly is, given the target-oriented dialogues, can we train the language model to basically direct the dialogues towards the expected answer, right? And then the third one would be the most difficult one, would be a non-cooperative dialogue. For example, a negotiation, right? I guess in business is, yeah, you want a chatbot to go and look for loan, to get a loan, yeah, to get someone to pay it up, yeah, yeah. So I suppose that's probably a simplest form of non-cooperative, task-oriented dialogue, yeah. So I guess if we do the standard one, which is given the background and history, and then ask the GPT to give the answer, which is what we typically do, then this just to show that the accuracy is not very high. But we can be slightly more proactive to instruct the GPT to say that maybe you should think about it, and then maybe you should ask to see whether you need to ask a question. Whether you want to answer now or you want to ask a clarification question. And this simple prompting actually will get the GPT to basically start to ask a little bit more questions, and then and get more answers to. This is still basically not good enough. Sorry, the format is all gone, I think, yeah. And then the third one, of course, is that I want to train it with some kind of a strategy, right? So basically, I will instruct GPT to say, can you analyze the question first to see whether the question is clear enough? And then, based on that, then you apply the action, right? There are two actions in this example, which is just simply answer the question, or you ask a clarification question. And then, of course, you can show that actually with this one, for this question, actually you got the answer right. I think overall, and the same thing for kind of non-cooperative dialogues and so on. I think overall, the key finding is that for the first two scenarios, it performs very well. And then, of course, it doesn't do quite well on vertical domain, which is on Fintech. And for the non-cooperative tasks, it's kind of still suboptimal in terms of coming up with the best option. I think for the negotiation task, actually there's no right answer. Basically, can I get the best deal for myself, right? And then the third one, the last one, I just want to quickly talk about would be the trust. So basically, you kind of trust and authenticity, bias, privacy, and so on. I think these are kind of all the issues that we need to look at. And then this is a multi-turn evaluation issue, right? So these are some approaches. I think given the time, I will not get into it. Just to say that there's some evaluation on kind of safety of LLM. Of course, you can do safety, you can do privacy, and so on. Basically, it's kind of to ask a question, and then to apply some of the poison prompts into the systems. So for the poison prompt could be role-playing, to get the GPT to assume that I'm certain character in a certain setting. So if you're kind of in an undesirable setting, then you ask GPT to say, describe yourself, right? Then they'll tell you all the things that you're not supposed to hear. Of course, the payload splitting is basically to split the question into multiple sub-questions. Each sub-questions are harmless, but the combination of answer could be review something that is unsafe. And of course, everybody knows about reverse prompt, right? I say, if I say I want to go somewhere to gamble, then the GPT say, well, I'm not supposed to tell you. Then if you ask GPT to say, I got a kids, where should I avoid so as not to get into gambling type of a situation, then GPT will tell you everything, right? So again, these are the things. So basically, this work is basically kind of to say how well the system now actually able to tackle all these things. And of course, I can do that for privacy, to say, if I ask a privacy-oriented question, does the system basically avoid generating those privacy questions to me, right? So one of the work that we hope to do will be the so-called audit in LLM. Basically, we can do the audit in performance, we can audit in content measures, and then we can also do audit in trust measure. And there's a long list of 20, 30 measures we can do for this kind of work. Okay, so I'll just quickly go through the last part. I think, So there are other things is that maybe you want to know the common capabilities of LLM, right? For example, can we do knowledge distillation technique to distill out the basic part of language model that kind of covers the common sense and things like that, personality and so on, yeah. So maybe I can have 5 or 10 more minutes, yeah, okay, yeah, thanks, sorry. Yeah, so I just quickly go through we found the language model era, I think probably for recommendation community, I think we focus on come up with better algorithms and things like that. And actually that has been working well, very, very well for us. And also we've been using kind of implicit user feedback, right? So these are all we can do. But I guess in the language era now we have pre-generated items, we have better user feedback and so on. So the question is, how can we take advantage of those? So I guess we all know from language model, we can actually have a richer word knowledge. It's able to generalize better. It has good interaction capability, natural interaction, and then able to generate personal content, right? So in fact, the language model can be used in 2 ways for recommendation. One is basically just to use it to help to enhance the feature, right? Language model can come up with a better feature, can have a better interactions, and then we still make use of the traditional recommendation model to do the recommendation, right? Another one will be kind of LLM-based RecSys, whereby the language model itself is trying to do everything. It will come up with a rank list, and then of course, based on the rank list, we try to attribute that to the item list so that we can present it in the same way. But language model is actually responsible for generating the rank list. And I would say here, the rank list also contains items that are actually not originally in the item space, right? So this is one work that basically, given the language model, can we use the kind of recommendation dialogues and things like that to fine-tune the recommendation model, right? For example, this one is basically come with 4M additional LoRa type of parameters, so that the language model is kind of trained to understand some of the recommendation type of interactions. And then, of course, if we do alpaca tuning, which is basically to kind of teach the language model to follow instructions. And then, this work basically done in USTC by Dr. I think, Feng, Professor Feng. I think basically it's kind of to show that with a simple tuning, actually we can improve the performance by a lot, right? So here you can see the 2 curves. The orange curve is basically just do the fine tuning with recommendation, and then the blue curve is with additional alpaca tuning, right? And then of course with the fine tuning to language model as well as with fine tuning to recommendation as well as alpaca tuning for instruction following, you can actually improve the result tremendously. Here is another work which is kind of following up that given that we use language model to transform the input into the recommendation space and then use a language model to generate the results, Of course, the last part is basically to kind of do the attribution back to the item list, so we can present the results based on the item list available in the database. But of course, in future, we might not need to do the last step, because if we have sufficient trust that the information generated by the language model is trustable, there's no need for attribution. In the way attribution, we are doing a step backward. Right? In fact, the generated result has contained a lot more information, and with attribution, we are actually reducing the information, right, into an item rank list. Lastly, I'll just quickly go through one work that there are some work that kind of try to use language model as an agent, and then to perform recommendation, right? So the hypothesis here is that language model has some human level intelligence of self-directed planning, instruction, able to perform planning and actions. So this is one example that we use the data from Movie Lens, that it has 1,000 agents, 3,000 movies, and things like that. And then use it to, first of all, train the item profile. Basically, based on historical ranking, then we can come up with a recommendation. And then we generate the user profile based on conformity, activity, diversity. These are just based on some statistical measure to say that, are you conforming to the overall groups, right? So this is an example that we use you said to generate the social attributes of diversity, conformity, and activity, and then below, basically, we use the language model to generate the taste, right? So now, based on this, we can then do the simulation. Given a question, the system will generate the recommender rank list. Then we can get the agent to basically do the item selection, item rating, and fielding generation, and so on. Basically, simulate what a human would do. And then based on this, we then feed back to the system and then retrain the system and so on. So just very quickly, just to say that based on this, our observation is that the agents are capable of preserving their own social attributes. That means they are the so-called their conformity, diversity, and so on. And then incorporating agents rating as augmented data, we can actually improve the recommender performance. Yeah. This is just one example of the so-called causal graph that we can generate from the results, right? So causal graph, you probably need to do causal discovery on the very big data, but we don't really have sufficiently big data to generate this. And based on the results of simulation, we are able to kind of come up with this to say that the exposure rate actually negatively impact the click rate, but actually increase the click number, right? So I think this is quite natural. If we overexpose something to a user, some user might not click. But of course, you expose it to lots of users, you get lots of click number, right? And then the movie rating is basically dependent on movie quality and click rate. I think these are just some of the things that you can draw from the insights derived from this causal graph. Yeah, so I think quickly I'll just end this by saying, yeah, it disrupted a lot of research activities, but a lot of work can still be done in academia, but of course, half of the audience here are from industry. Yeah. So I guess we can understand the fundamentals of LLM, I think, which will be important. What are the limitations, the boundaries, that in terms of trust, in terms of audit, maybe we should think of network experts rather than a generalist, and then how to do human in the loops, and other foundation models for multimodal and life science and so on. Yeah. So I just kind of want to end, yeah, that there are always disruption in technology, and we can always pick ourselves up and then move on, right? And then the opportunity here is that we can do a lot of things a lot more easily now, given the capability of language model, and I think it's generally basically positive for the whole field. Yeah, so I'd like to end here. Yeah, thanks.
Thank you very much, Professor Chua, giving us a very inspiring and in-depth talk on using the language models related issues. So I believe that we could have several questions for anyone here in the room have the question. And also we could have 1 or 2 questions online. Yeah. Okay, if you have any question, you can go to the microphone to stand there in front of them. And when people are just moving, there are two questions from the several questions online. The first one is asking, can you please give an example of long tail knowledge specific to recommender systems?
I don't have any example, but I guess the experimentation did by that work that I picked it up from the archive actually kind of shows that language models supposed to know the Wikipedia knowledge very well. But the example shows that if we do additional retriever to answer the question from Wikipedia, I can get a kind of a substantial improvement in the performance. Which means that the language model actually are not able to represent the knowledge very well. I think to be expected because we wouldn't know how language model represent the knowledge in terms of, I don't know, 7B to 400B of parameters, right? So some of the knowledge will be lost. Yeah, but it will be good. I think we will think about that questions, I think.
Okay,
yeah.
Thank you. I think there is a question, please.
Hi, awesome talk. So this is Yifei from Amazon. So you mentioned in one of your slides that if you use large language models for recommender systems, you can preserve the user's social attributes. I guess the question is related that, in recommender systems, there's a lot of regulations concerning how much privacy or how much, we shouldn't learn about the user. So since you mentioned social attributes, I wonder, have you had any thoughts about sort of the compliance side of user studies?
Yeah. So for this one, actually, we didn't really make use of any of the users' personal info. It's just the click history. And then basically we kind of do a statistical to say, does the clicking conform to the majority? Yeah, does the activity kind of above the norm or below the norm? And then based on that, basically, so we say social norm is just to whether it preserves the user's kind of activity behavior. Yeah, so it's not I guess the word social norm might conjure that like we actually mine a lot of kind of user personal data from there, but we didn't do any of those, yeah.
Yeah, thank you.
Yeah. So I think that would be one of the key problems that we need to avoid. I think.
Yeah, exactly. So you can ask large language model, right, what do you think about this person based on their behaviors? And they might give you some answers you don't want to hear.
Yeah. I think that's a very good question on so-called agent-based or there are lots of examples whereby I use different language model to do kind of counter each other and things like that. The basic question is, does this different agent has sufficient independence or orthogonalness in thinking, right? So how to inject sufficient kind of personality there. But one way I think we discussed with some of them, one way we want to argue is actually in this audience, probably all of us, probably 90% of our background are the same. So maybe we think similarly 90% of the time, only 10% of the times are different. So in a way, it's still reasonable to use language model to model that. The question is, how can I inject that diversity of that 10% into the simulation? I think that is just the beginning of the work. I think that's a very good question that we need to learn, actually. Yeah.
Okay. There is another question from online asking, recently people also explore generation reference in long text generation for reliability. So what's your opinion on this direction?
Sorry,
yeah. This one? For long text generation for references. So what's your opinion?
I think I mean, my position would be actually anything that is generated, we need to be careful, right? That's why I think all the work now, even the search engine, we try to attribute that to an item. But of course, in terms of information value, information content, when you attribute back to the item to say that you are actually reducing the information. So the question is, how can we preserve the rank list or description generated by the language model, and then also ensure that it's accurate? Yeah, this is a hard question. I think that this is probably all the work that I mentioned there on trust evaluation. Can we make use of multiple means, reliable sources, knowledge, as well as kind of self-evaluation to basically do to attribute some trust to the system. Yeah. So I think this is ongoing work, and then basically I would hope a lot of you will focus a lot more efforts on this. Yeah. Sorry.
Hi, thanks for the talk. Luis Pesato from Commonwealth Bank of Australia. When we used to attend conferences like this, right, we're always trying to build large language models. We're trying to build all these systems. But you're all very interested in how to use these kind of tools, right? I just have this feeling that we're almost becoming a psychologist of a machine, right? We're trying to dig into this brain, try to understand how it works, try to understand how to control it. Do you see that the community in general is changing a little bit from building to using? Or how do you see this evolving?
Sorry, what's the last part?
If the scientific community, like RecSys, SIGIR, we are focusing on using these brains instead of building techniques to do the same thing that the brain does.
Yeah. I guess this thing only happened about 1 year plus only, I think, yeah. So we kind of, in a way, from a bit of loss to kind of finding directions. I think this one directions we found. And we kind of, in a way, I'm saying that trust is probably something that we in the academy can do well, and then we should do a lot more and things like that. And of course, as we start to do, probably referring to the last work that we kind of, now we actually try to simulate agents, try to simulate this and that, and then the question is, do they conform to human, or we are actually simulating something that is kind of anti-human type of behavior and things like that. I think this is something still open. I think my take is that we should not use too much of the personal info for those. I think we should try to use as much of the kind of so-called, I don't know, extracted group identity and things like that to do all this kind of simulation. And we should always think about how can we inject diversity. Yeah. I think we just talked about it. In fact, the diversity is probably one of the key elements of language model. In fact, they differentiate between the very good language model and the ordinary language model because of the diversity. And with diversity, they can do things in a different way, and then so we can actually simulate in a better way. And currently, I suppose you can say GPT-4 has all the attributes that we are looking for. And it's basically it's up to our community to say how can we make use of that to simulate we human in a safe and privacy-preserving and unbiased manner. I think these are some of the work that we academics should be looking into. Yeah, thanks for the questions.
Okay, any other questions from our audience here? I think that we only have time for one last question. Okay, so there is some online questions, but we could only ask or have time to ask one. It said that large language model is so large that it's challenging to deploy on the online real-time recommendation systems. So any idea to reduce latency or any other points on this?
I guess the answer would be, I guess right now, I think all those get deployed are probably Llama 2 type of system with over 7B, right? Which most of the medium-sized or most of the tech company can actually able to run it, I think. Yeah. So the question is, if you do Llama 2 type of system, how much of the inference and then language capability you lost? I would say that it might be okay, because I think we need to think of, can we use the Llama 2 and this kind of model just for language and common sense capability, whereas the knowledge still has to be injected in. It's just one example. So if I apply it to Fintech then maybe I need to infer a lot of fintech knowledge in there, and then so that we are kind of trying to kind of train experts for different applications, rather than come up with a huge 300B model for applications, right? So I think I already see this thing already being happening in industry now, that a lot of 7B type of Llama 2 models are being deployed at the moment for doing this sort of applications. So I think this trend will continue. Of course, as the system gets cheaper, we probably can go for bigger and bigger model. Yeah, but definitely not the 400B model.
Okay. Okay, let's thank Prof. Chad again for the wonderful talk and question answering. And yeah, this is a souvenir from the conference for you.
Okay.
Thank you.
Okay. Yeah. Okay. Thank you very much. Yeah. Yeah. I'm around, so I guess if you got any points, we can actually have a discussion later. Yeah. Thank you.
Okay. Please enjoy the coffee break now, and please be sure to turn back to the conference room at 11:15.